Okay, okay. So let's talk about significant figures. Okay, so why do we talk about significant figures? Let me tell you, significant figures, as the word suggests, significant means important. Significant means important. Figures are the digits, okay? What do we mean by important? It has a lot of meanings. In in physics, chemistry, and in math, we will deal with significant figures. It means, first of all, most accurate or most reliable digit in a number. Most accurate or most reliable digit in a number. Okay, and second, highest value. Okay, value. What value does it have? Okay, so most accurate, most reliable, and the value. Okay, these are the two meanings of a significant figure. Okay, that's what we mean by significant figure. Okay, now when we are measuring using any apparatus at all, there is some limitation. We can never be 100% accurate. We can never be 100% accurate. Okay, now that error can be due to the apparatus or can be due to human error. Okay, can be due to anything. So in either case, when we write a number, we have to know how many digits in this number are reliable. Okay, okay. Now, the more the significant numbers, or the more the significant digits in a number, the more accurate that number is. Okay, now what do I mean? For example, I made this. This is a ruler. Okay, like a ruler that we have, an ordinary meter ruler, like this. Like if I have a ruler, if for example I have a ruler, now what decimal place, accurate to what decimal place can I have a reading using this ruler? So I have enlarged 1 centimeters. This is 1 centimeters. Okay, starting from 0 to 1. What is the most accurate value that I can get? The most accurate value, let's say, for example, if something is 0.4, if something is 0.4 centimeters long, okay, this is the most accurate I can get. Why? Because if something touches this line exactly, I know exactly that this is 0.4. But what if something lies here? What if something lies here? Is this midway between 0.3 and 0.4? Or is it more than midway? Or is this less than midway? I don't know. I can only guess, or I can only estimate. And how much more than midway? Or how much less than midway? That is also yet to be decided. We don't know. And I can never 100% say that, okay, this is 0.35. I cannot say that for 100% sure. It can be 0.34, or it can even be 0.36, or it can even be 0.33. I don't know. Okay. So that means I am sure about 0.3, but I'm not sure about the other digit. I don't know about this digit. It can be 6, it can be 4, it can be 3, it can be 5. Okay, so I don't know about this digit, but I am sure about these two. So that means that this is not significant. In 0.36, this is not significant. Only this is significant. 3 is significant, okay? And we will do the rules of significant figures, but for now the point that I'm trying to make here is that, did you see that this instrument, a meter ruler, can give you an accuracy of only 1 decimal place, not more than that. This meter ruler can give you accuracy to only 1 decimal place, meaning that only 1 digit after the decimal. That's it. You cannot have a reading like this using a meter ruler, 0.3, 4, 5, 6. 3, 2. You cannot have this sort of a reading using this meter ruler. You cannot go this accurate. Okay. Okay. Now, having understood this, so this is a limitation of this meter ruler. In the same way, we can increase the accuracy by using more accurate apparatus such as a micrometer or a vernier caliper. Those are more accurate apparatus and instruments to measure length, but still they are also not 100%. We humans can never be 100%, no matter what. We can get close to 100, but we can never be on 100. We can never reach 100, okay? So having understood this, that's why it is important to understand what are significant figures. So let me first read out the rules of significant figures for you, and then we will discuss them, okay? So significant figures meaning what are the reliably known digits? Of the digits, which one are you sure that it's absolutely only that digit? It cannot be any other digit. For example, in this example, we were sure that we were 100% sure about 3. Okay, but we were not 100% sure about 6. Okay, so reliably known digit was 3 here. Okay, so that's what I mean to say reliably known digit. How sure you are that a digit is accurate and not an estimate. Okay, the digits, for example, this other digit 6, 5, 4, these can be estimates. I can estimate them. I can say, by figuring out that it looks like it's midway, so I can say 0.35. So 5 was my estimate. So 5 is not significant. Okay, so let's just start with the rules of significant figure. All non-zero digits are always significant. Why? This is very easy to understand. This is common sense. Non-zero digits, why do you write a non-zero digit? Because you are 100% sure that that is what it is. Like, for example, in 5062, I know for sure about 5, about 6, about 2. Okay, and also about 0. So all the non-zero digits, we use them because we are sure about them. So all the non-zero digits are significant. Zeros, which are, can you please zoom out? Leave it like that, okay? Zeros sandwiched between non-zero digits are also always significant. Zeros which are sandwiched between non-zero digits. Sandwich meaning they are lying in between the non-zero digits. So zeros that come in between the non-digit numbers will also be significant. Why? Because when we estimate, we don't estimate a 0 in the middle. Our estimations are either at the end or can be before the number, but never between the non-zero digits. We don't estimate the zeros in between the non-zero digits. So that will always be significant. Okay, now this I will discuss afterwards because this is confusing. First, let's deal with the easy ones. Now, zeros that come at the end of a number may or may not be significant. Okay, the zeros that are at the end. Now, let me talk about this in a little more detail. For example, let's say that I am talking about the population of Pakistan. The population of Pakistan is, for example, I tell you that the population of Pakistan is 200 million. Okay, 200 million. I give you this number and I tell you that this is the population of Pakistan. Now, of all these digits that you can see in front of you right now, which digits do you think that I am 100% sure about? And this is a question. I want to see raised hands. How many digits are you sure that I am 100% sure about of these digits that you have written in front of me? Okay, Osman, very good. Yes? Is there any problem with my, I cannot hear him.
Two.
Yes, Zainab? Yes, Usman?
Yes, two.
Two, which digits? Which two?
This one too. That yeah.
Oh, okay, this two. So is there any other digit that I'm sure about, or is this the only one?
Yeah, only one.
The
I
only one?
think only one. Yeah, I think only one.
Okay, why am I not sure about the others?
Because we are not sure that there are so many people and they are always increasing.
Very good. Very good, Usman. Good job. Yes. Yes, your answer is correct. Correct. Absolutely correct. So we are sure only about two. We don't know about these zeros. These may be estimates. These may be estimates, or they may be accurate. We don't know. And since we are talking about the population of Pakistan, we know that counting population is a highly difficult job, and it is open to many errors, many errors. We cannot even count how many factors can come into play. And so the population of Pakistan may not be exactly 200 million, but this definitely is an estimate. Now, somebody might say, okay, so this zero might be an estimate, but what about these other zeros? Or okay, let's say the last three zeros are estimates, but what about these five zeros? Or okay, these six zeros might be estimates, but what about this 200? What about these two zeros? No, all of these zeros may or may not be estimates, may or may not be. Okay, let me give you the exact figure that I got from Google. What is the population of Pakistan currently? I mean, according to the latest census, it is this. Can you see? It is this. Now, if I want to estimate this big number, this is a big, humongous number. Now, if I want to estimate it, I can estimate it to the nearest 100, to the nearest 1,000, to the nearest 10,000, to the nearest 100,000, to the nearest million. Okay, so let's see. If I want to round it off to the nearest 1,000, my answer would be 892,000, right? And so that means these three zeros are estimates. So these are not significant. Okay, I hope you guys know how to round. Okay, for this, to understand this, you have to know rounding. Okay, so if I'm rounding it off to the nearest 1,000, that means I should have three zeros. So I will go back three digits and look at the digit before the third one. Okay, and so that should be my last digit. But before rounding, before rounding off, I have to check the digit which is right next to the last digit. If it is greater or equal to 5, this digit will go up by 1. And if this digit is less than 5, this digit would stay as it is. This is rounding, okay? I hope you know that already. And if I round it off to the nearest, let's say million, so that would be this. That shows all these 6 zeros are estimates. Okay, so that means these zeros are not significant because we are not sure if they are accurate. Do you understand that? And so on and so forth. Now, even this zero, we are not sure about this. Maybe it is 221, or maybe it is 219. We don't know. Maybe it's 222. We don't know. Okay, and even this, yeah, okay. So that is how the trailing, these are called trailing zeros. Why are they called trailing zeros? Trailing zeros are the zeros that come on the right hand side. Okay, trailing zeros, they are trailing, like they are at the end. Okay, so the zeros which are on the right hand side of a number are called trailing zero. They may or may not be accurate. Okay, now why am I saying may or may not be? I'll give you another example. For example, I say that my book, my physics book has 400 pages. Okay, if I say that my book, physics book, has 400 pages. Okay, and this is the number of pages in my book. Now, why am I writing this? Because this information, I'm giving you this information myself. I'm giving you this information. Okay. Do you now tell me, are these two zeros significant or not? Do you think, now before you answer this question, ask yourself, are these two zeros estimates or are these zeros actually there? And these are the number of pages in my book. Yes, Zainab. Yes, Zainab?
I think, Miss, those two zeros would be significant figures.
Yes, why?
400 isn't a very, very big number, so you can count it.
No, well, you gave me the correct answer that those two zeros are significant, but your reasoning is not correct. See, reasoning is that I told you myself. I can, I don't even have to look, I don't even have to count the number of pages. I saw the last number page and I told you there are 400. Okay, I saw the last page number. Okay, I saw the last page number. For example, this is my physics book. Okay, let's suppose, yeah, 300. Okay, for example, this is the last page. I'm just giving you an example. I know for sure it's 300. Okay, this is not an estimate. This is not an estimate. This is actual 300. So I know for sure it is 300. These two zeros are not estimates. So that is why these two zeros are significant, because they are accurate. That is why. Okay. Okay. For example, if I say that I will take exactly 50 students in my class, for example, that if I actually mean it, the zero is an accurate number. And I tell you myself, okay, if I don't tell you that these are the pages of my book, I just give you a random number, 400. That's it. Write down the number of significant figures. And I don't tell you what it is. You don't know if it is a population or the number of students in a class, or is it a number of pages in a book. Then tell me how many significant figures are there. No other piece of information. Yes. How many significant figures? If I don't give you any other piece of information. So ask yourself, are these two zeros, are they estimates or are they estimates or are they accurate? Yes. Yes, Abdul
I think so. I think so. They are estimate.
Very good. Yes. Okay, another rule. Let me tell you another rule. We in math, we don't, how should I put this in words? Like we don't put precision more than, like, how should I put it? See, we cannot be more precise than actually we are. Okay, to be on the safe side, we take the less precision. We take, okay, I'll explain this to you with the help of a question. Okay, maybe I'm not able to put it in words. Meaning, to be on the safe side, you cannot be over precise. Okay, this is another way to put it. You cannot be more precise. If I say that this has 3 significant figures, if I say that this is 3 significant figures, that means I'm trying to say that this is all the 3 digits are highly accurate. All the 3 digits are highly accurate. Well, that is not the case. This might be estimate. To be on the safe side, I will take them to be estimates, and I will say that only 1 significant figure. That means its accuracy level is a little low. Okay, to be on the safe side, we categorize the numbers as less precise. I mean, we don't want to what should I say? I'm running out of words. Okay, let's move on. So did you understand this? Okay, another thing. If, for example, I have decimal 400.0. Okay, now this decimal is telling me that I am pretty sure about these zeros. I am pretty sure about these zeros. I'm not just, this is not estimate. Okay, I know what this means. What this means to say is that this is not 499. This is not 499. This is not 489. Okay, this is not an estimate. This is not 401. This is not 402. This is exactly 400. And this is also not 400.1. This is not 400.2, but this is exactly 400.0. Okay, therefore, this figure, because of this decimal has brought in so much accuracy to this number that now this number has 4 significant figures, 1, 2, 3, 4. Okay, this has 4 significant figures. Even this 0 is significant. Why? Because it is telling us that we know the accuracy to 1 decimal place, to 1 digit after the decimal place. But after that, we don't know. We don't have that accuracy. After that, we don't know. Okay. Do you know that there are infinite numbers of zeros before the decimals and infinite number of zeros after the decimal? Infinite means uncountable. Uncountable. But we don't write them. We don't go ahead and write them. We only write the digits that we are sure of. Okay. So the decimal places that we write in any number shows us how sure we are about these digits. Okay, so that is why so the rule is that if you have a decimal, then the trailing zeros are significant, meaning they are accurate. And if there is no decimal and we have no other piece of information, then the trailing zeros are not significant. I hope I made sense to you. So I'll read this rule again. So if there is decimal, the trailing zeros are significant. If there is no decimal, then the trailing zeros are not significant, provided you don't have any other information. Okay. If in the question they give you some information, then you have to decide accordingly. If you think that that was an estimate, then you will not count the zeros because they are estimates. But if the situation in the question is telling you that yes, they can be exact about these zeros, then you will count those zeros as significant. Okay. Now, when you do have a number like this, out of these digits, which one is the most significant? In this number, which digit is the most significant? Yes. Yes, Abdul Wadud.
Yes, 2.
2. Why?
Because it is, we only know that.
Yes, your answer is correct. Yes.
Can't explain.
See, what are the 2 things I told you in a significant figure? You talk about accuracy and you talk about also the value. Value. This has the highest place value, right?
Yes.
Yeah, this digit has the most value of all the digits. As you go on the right hand side, the value of digits decreases. So much so that this digit is just unit. And this is 100,000. This value is 100,000. Remember, we did this place value. So this has the most value, first of all. And secondly, this is the most accurate as well. We can estimate and round up these numbers. Please mute yourself. We can estimate these other digits, but this would stay reliable. This would stay accurate. Okay, so that is why this is the most accurate and this is the most valuable. Okay, now let's talk about this rule that I skipped because I thought I will explain this at the end. I find the leading zeros the most confusing. Leading zeros, trailing zeros, we talked about the trailing zeros, but we did not talk about the leading zeros. Okay, let me, for example, 0.00024. Okay, now these are non-zero digits. Okay, so they are significant. We know that they are significant. What about these? Now these are leading, meaning they come before the number. They come before the non-zero digits. Now they are not significant. They're not significant. Why? The question is why? I used to get confused. Even now, you know, I find this the most difficult to explain. Yes, okay. So now the thing is, remember, I told you, we cannot write a number with a precision greater than what it actually is, okay? For example, what is the point that I'm trying to make is that, for example, if I have 25 centimeters, okay, let me give you this example that I just gave you. This. Remember, we can only have 0.3, right? We can have only 1 digit precision with this meter rule, right? Now, if, for example, we have a paper, okay, and we have to calculate its area, right? We have to calculate its area. Area is length multiplied by breadth, right? Now, let's suppose the breadth is 0.3 centimeters, just example, okay? For example, the breadth is 0.3 centimeters and the length is, let's suppose, 0.5 centimeters, okay? Now, area would be 0.3 into 0.5. 0.3 into 0.5 is 1.5 centimeters square, right? Now, how many significant figures are here? 0.3, only one, because this is not a significant figure. This also has only one, because this is not a significant figure, okay? So we have one here, okay? But this has, the answer has, oh, sorry, the answer is 0.15, sorry, okay. So this has how many significant figures? So 0.3 had one, this has one significant figure, this has one significant figure, but the answer has two significant figures. So are we trying to say that these numbers are less accurate and the answer is more accurate? Are we trying to say that these numbers are less accurate and the answer is more accurate? Now, how can you get something more accurate from less accurate? You cannot get, okay? You cannot get an answer which is more accurate from less accurate numbers. Okay, therefore, the answer also should have only one significant figure. Okay, so we will round this off. We will round this number off to one significant figure. Okay, so this would be it's 0.15, right? So I want only one significant figure. So I will look at this is 5, this is 5. So I will increase this to 0.2. So it would become 0.2 centimeters. That's the answer. That would be the answer. Okay. So what I'm trying to say is that when you multiply two numbers, the answer cannot have significant figures greater than the factors that you are multiplying. Okay. Okay. Now, the point that I was trying to make, also another thing that you should remember is that, where did I write that? I wrote down a few rules here. Okay, also remember that if we write a number in a different way, or if we write a number in different units, the number of significant figures should not change. What do I mean? What do I mean? For instance, I have 25 centimeters. Okay, for example, I measured something with my meter ruler and I got 25 centimeters. Now, if I want to convert this into kilometers, no, don't zoom in. If I want to convert this into kilometers, I get this. Okay, 0.00025. So from 25 centimeters, I got 0.00025 kilometers. Okay. So how many significant figures are there in 25 centimeters? 2. And how many significant figures here? Again, 2. But what I'm trying to explain here is, why am I not counting these leading zeros? Can you see that this has no decimal at all? Absence of decimal means it is less accurate. I mean, the accuracy level of 25 centimeters is less. And look at the decimal places here. How many decimal places are these? 1, 2, 3, 4, 5. 5 decimal places. So do you think that we measured this with so much accuracy? No, we did not get more accurate. We have just converted 25 centimeters into kilometers. And so if we would count these zeros as well, that would mean to say that this has 5 significant figures. That means the accuracy level is too high, but which is not true. Therefore, remember, we do not count these zeros, which are leading or which come before the non-zero digits, whether there is decimal or not. These leading zeros are never, ever significant, never, whether there is decimal or not. Okay. Okay, so with that, so I hope I made sense, and I hope so. What I was trying to do was that I was trying to make sense of these significant figures rules. Otherwise, you know, people just go ahead and memorize them and they just follow it. So you can do the same, but I did try my best to make sense out of it. Okay, in the last class, you guys learned how to write scientific notation, remember? Sundus discussed how to write scientific notation. So if, for example, I want to write 0.25 meters in scientific notation, how will I write it? Remember, a number which is between 1 and 10, multiplied by 10 to the power anything. Okay, can be minus, can be plus. So 0.25 meters can also be written as 2.5 into 10 to the power minus 1. Is that right? Okay. How many significant figures here? 1, 2, right? 2 significant figures. And then how many significant figures here in scientific notation? Excuse me, how many significant figures in scientific notation, Sundus? Say it loudly.
2 figures.
2 figures, why? We don't count this. We don't count 10 to the power, whatever this is. We don't count this. We only count the number which is getting multiplied by 10. So in this number, there are 2 significant figures. So 2 and 5. So remember, whether we write it like this or we write it like this, the number of significant figures should not change. Why? Because we are only changing the form of the number, the way in which we are writing. The level of accuracy and the value of the number should stay the same. The level of accuracy does not increase or decrease by the way we write. Okay. Okay. So, okay. Once if you have understood that, now how do we multiply and divide numbers with significant figures? So one, I already gave you an example. Okay, let's do this. Okay, let's do this first. Let's round off this number to 1 significant figure. Let me do 1 and then I will ask you guys to do it for me. So I'm rounding off this number to 1 significant figure. Okay, 293568. And as Abdul Wadud told us that 2 is the most significant. So I will start from the left-hand side. Okay, and I want only 1 significant figure in my answer. So I will write 2. And because I don't want any other significant figure, rest of all these numbers will turn to 0. 1, 2, 5, right? So I have now rounded this off to 1 significant figure, which is 200,000. Now, who will round this off to 2 significant figures? Yes, Zainab? Who will round this off to two significant figures? Ahmad.
Yes, ma'am.
Yes.
We will add 290000.
Right, 290,000. Why? Because two significant figures means, yeah, go ahead and mute yourself. Thank you very much. That's correct. So 2 and 9, I will keep these 2 and 9 because I want two significant figures, and then I will check the next digit. It's less than 5. And so this digit 9 will stay the same and rest of all the digits will stay 0. Okay. Now who will round it off to three significant figures? Rahim.
Yes.
Yes, three significant figures. Can you round this off to three significant figures?
Yes. The answer will be 293,000.
Right, 293. No. See, you will, now because you want three significant figures, so you will take the first three significant figures because these are the three highest value digits. So you will take 3, 9, and 2. But before you write down the final answer, check the digit which is right next to them. That is 5. That is 5. So that means this will increase by 1 digit. Okay. So Rahim, what is the final answer?
294,000.
Right. 294,000. Okay. So this I guess you guys know. Okay. Now let's do this. 0.07604. Now round it off to one significant figure. One significant figure. Momina.
Yes.
Yes, Momina, can you round this off to one significant figure?
0.1.
0.1. How did you do that? Did you try to say that I'm not asking one decimal place. I'm not asking you to round it off. You have rounded it off to one decimal place. I'm saying round it off to one significant figure. That's different. By one decimal place, meaning that you should have only one digit after the decimal. But that's not what I'm saying. I'm saying my rounded off figure should have only one significant figure.
So the answer will be 0.
0?
Yes.
That's it.
0.00000.
No, beta. No. Okay, Sundus, you tell me.
Is it 0.0761? 0.0760.
Acha, एक minute. Let me wait. I will write down the answer you're giving me. Tell me the answer. What did you say?
0.0760.
760. 0.0760. How many significant figures are in this answer? Can you count with me? Yes. How many significant figures in this?
4.
4?
5.
5. Wow. You understood so well. No, not 2. No, you're all wrong.
3.
Yes, 3. Yes, 3. Because these two zeros are leading zeros. I told you leading zeros are never ever significant. So they are not significant. So, but the end zero, the trailing zero is significant only when there is decimal. Only when there is decimal. When there is decimal, the trailing zero is significant. So this is 3 significant figures. So this is wrong. I am asking you to give me an answer rounded off to one significant figure. Okay, let me do one. Okay, let me do one. I'll tell you. what you do is from the left hand side. Why from the left hand side? Please, can you please zoom out a little? From left hand side, you mark the first significant figure. Okay, this is how you should do. This is the procedure. From the left hand side, you mark the first significant figures. These two are leading zeros, they cannot be significant. So these two zeros are out. From 7. Okay, now you want the answer rounded off to one significant figure. You don't want any other significant figure. Okay, so but before you write down the final answer, look at the digit next to it. It is greater than 5. So that means this digit will go up by 1. Do you understand? And so my final answer should be 0.08. And that's it. I cannot add zeros. Why? Because they will be significant. And I want only one significant figure in my answer. So this is my answer, and only this is the significant figure in my answer. So the answer is 0.08. Say it loudly. I cannot hear you.
Why can't it be 0.1?
Why can't it be 0.1? Because you have to, because remember, the figure that you get, the answer that you get should be close in value to your actual value. You have to be close to the actual value. Okay, and this is the procedure. The procedure is you start from the left-hand side. You start from the most significant digit from the left-hand side. You start rounding off from the most significant digit from the left-hand side, and remember the last answer, the final answer, should be in closest in value, closest to the actual value that you have. Do you understand that?
Yeah.
Is there any question? Ask me. Okay. Now round this figure. I'm gonna write it again because I crossed it up there. Now round it to 2 significant figures. Usman.
Yes. Teacher, I have 2 questions. Okay, let me tell you the 2 significant figures first. It should be, I think so, 0.080.
0 point, can you please tell me again? 0 point?
0.080.
Yes.
80. 80.
Okay. Okay, beta, this is wrong.
Teacher, I have one question more. Can you move to the back to the question number 1 that you did?
Your voice is breaking. You want me to do what? The previous question? Which one?
Yeah, please can you move to the first question that you did?
Okay, this. This?
Yeah, teacher. Yeah.
Okay.
Yeah, teacher. For there, it is 293. So why isn't 9 rounded with 2? It should be 300.
In which part? 1 significant, 2 significant, 3 significant? Which one?
One significant. One significant.
Yeah. So in one significant figure, I want only one significant figure. That's it. The rest of them.
Why isn't it 3? Because there is 9 in front of 2.
Oh yes. Oh yes. That's my mistake. Thank you very much. Yes. Okay. Yeah. You know, yeah. So you guys are very good at taking out my mistake, but you don't understand what I explain you. But thank you very much, Usman. Yes. So the thing is that before I write down the final answer, I have to look at the next digit, and it is quite big, and so this should be 300,000. Very good, Usman. Okay. So now, Usman, why is this answer wrong? I will explain this. Okay.
Okay.
Yes. And stay with me. If you don't have background noise, you can stay unmuted. Okay. Now the thing is that what you have done is, I don't know what you have done, but this is the proper way. You start from the left-hand side. You start from the left-hand side from the most significant digit. And we know that on the left-hand side, the most significant digit is 7. Okay, but I want 2, right? In my final answer, I want 2. So I will take 7 and 6. Okay, let me use some other color so that, okay. So I want 7 and 6. Now, before I write down the final answer, I will look at the next digit, but the next digit is 0. So that means 6 stays as it is. So the final answer should be 0.076.
Okay.
Did you understand?
Yes.
Okay. Now do this 3 significant figure with me. Now round this number. I'm going to write the number again. 0.07604. Now round it off to 3 significant figures. So start from the left hand side.
Yeah.
Is 7 significant?
Yes.
Yes. 6 is significant?
Yes.
Yes. Is this 0 significant?
Yes, because you said that the 0 sandwich between 7 and 6,
Very
0,
good.
4 will be significant.
Yes, yes. So that means these are the 3 significant figures that I want in my final answer. But the thing is, before I write down, I will check this digit. Is this greater or less than 5? This is?
Less than 5.
Less than 5. That means this digit will stay as it is. So my final answer would be 0.0760.
Okay.
Okay? This is rounded off to 3 significant figures. Is it clear? Is it clear, Usman? Okay. Okay. So if there's any question, please raise your hands and we will do more examples. We will do more examples. Yes. Okay. Are these raised hands questions? Okay. Farzan, is there any question? I'm unmuting you. If there's no question, please lower your hands. Abdul Wadood? Okay, no questions. Okay, good. Now let's deal with the multiplication, division, addition, and subtraction with significant figures. Okay, this is important. Now, I already told you that a product is the answer that you... Can you please stop zooming in and zooming out? Leave it, I'm fine, okay? Just hold it this way. Okay, sorry about that. So the product can never be, product is the answer to multiplication. Product is the answer to multiplication that can never be more significant than the factors. Factors meaning the number that are being used for multiplication, okay? And quotient is the answer to division problem. That can also be never more significant than the numbers that you're using for division, the number that are getting divided. I mean, how is it possible that, you know, you are multiplying, I mean, you are using 1 decimal accuracy for a measurement of, let's say, a volume of a box, and then the answer is, you know, 0.234 something. This means to say, you know, these digital places, these digits after the decimal mean to say that you are very sure about these digits after the decimal, which you are not. You simply got these digits because you multiply, that's all. Therefore, the final answer should have the exact same significant figures as the significant figures in the numbers. Now, the thing is, the question is, now let's do a couple of examples, okay? 62 divided by 41, okay? It gives me this big answer, okay? Now, I can see that 62, this number, has only 2 significant figures, okay? This also has only 2 significant figures, okay? But look at the number of significant figures here. So does that mean that this has, you know, higher accuracy compared to these 2? No, that's not true. So therefore, this answer should be given to the same, it should have the same number of significant figures as the numbers which are getting multiplied. So since we have 2, since the numbers have only 2 significant figures, our answer should also have only 2 significant figures. So we will start from the left-hand side because they are the most reliable, the highest place value. So I will start from left-hand side. So 1, okay, is significant. 5 is significant. So 1.5, and then I look at the digit next to it. Is it greater than 5? No, it's less than 5. So I leave 5 as it is, and that's my answer. And do not add any zeros, because if you will add zeros, they will also be significant because you have a decimal. And you cannot have more significant figures than the numbers that you're using for division. Okay, remember that. Again, same is the case here. Here, the significant digits are 3. Here, 3. So the answer should also have 3. 1, 2, 3. But look at the digit next to the third one. That is great. That is equal to 5. That means this number will go up by 1. So this would become 3.39. Okay. Again here, 1, 2, 3, 4. 1, 2, 3, 4. 4, 4. So is this significant? No, I will not count this. 1, 2, 3, 4. But this is 0. So this will stay as it is. So the answer would be 0.3521. Okay. And then so on and so forth. Okay. Tell me, round this off. What should be my answer? 56 multiplied by 28. How should I write this answer? How many significant figures? What should be my answer? Yes, Ahmad 31. Huh? What happened? Ahmad 31 and Zainab vanished. Okay. And please go ahead and ask questions. It's okay. I understand this is very complicated. I mean, this is a little confusing topic. Yes, Zainab?
Miss, since
Yes.
both 56 and 28 have two significant figures, the final answer should also be in a two significant figure. So it should be 16.
16.
1, 6. 1,
That's it.
6. Yeah.
That's it. 16. So 56 multiplied by 28 is 16.
No.
Yeah, then what about these two digits? They will turn into?
Zeros. Two
Yeah, so you will say 1600. Okay, be careful. Okay, it's okay. So the thing is that when you write the final answer, be sure that the value is roughly equal to the, I mean, roughly close to the actual value. Okay, okay. Now who will do the next one? Ahmad, no, let's see. Okay, Ahmad, okay, Rahim.
Yes.
Yes, Rahim. What should be my final answer here?
8414000.
Yes. So because there are 4 digits, 4 significant digits in these factors, so my answer should also have 4 digits. So I will start from the left-hand side. So 1, 2, 3, 4, and this is less than 5, so it will stay. So it would be 8414, and then the rest of the digits will turn into 0. Okay, good job. You guys are getting the hang of it. Okay. And then, now what about this? Who will do this? Who will do this? I did not explain you this, by the way. So let me explain it, then I will ask you. Okay. So how many significant digits here? 1, 2, 3, 4, 5. And these are only 2. Okay. Now, what should my final answer have? Remember, I told you to be on the safe side, we do not write a value. We do not write a value which is more precise than what it actually is. We can be less precise, but we cannot be more precise. Okay. So we will choose the lower accurate value. We will choose the low significant figure. I mean the number of significant figure which is less of the 2. So we will choose the lesser one, okay? Because this has 2 significant figures, so answer should also have 2 significant figure only. So that means I will choose 6, I will choose 4, but then that's it, okay? Now this is greater than 5, so this will go up, 4 will go up by 1, and my final answer would be 6, 5, 0. That's it. No decimal. No decimal. Why? Because if I put a decimal, then this also would become significant, and that means the answer has 3 significant figures. But answer should have only 2 significant figure. Okay? Answer cannot be more significant than the factors, than any of the factors. Remember. So my answer would be 650 without any decimal. That's it. Because this trailing 0 is not significant. So in my answer, I have only 6 and 5 significant. That's it. So can you see that the actual answer has a decimal, but my rounded off answer does not have a decimal? So is that a problem? No, that's not a problem. Why? Because even this factor does not have a decimal. Even these factors did not have decimal. So that's fine. Okay. So remember this. Okay. Okay. Now do this with me. Do this with me. Who will do this? 5621 multiplied by 893 giving me this. So round it off to the appropriate significant figures. Okay, Abdul Wadud.
Ma'am, I wanted to ask a question.
Yes, okay. Yes.
Ma'am, you said that the trailing zeros, they are not significant. I didn't understand that.
No, they are not significant if you don't have any other piece of information. It depends upon the situation, or if there is no decimal. You did not understand that? I gave you the example of the population of Pakistan, how we are not sure about the accuracy of the trailing zeros. And those zeros are just estimates. They can be any figure. For example, if somebody says there are 9 million stars in the sky. Now, are you sure that there are actually 9 million? Or maybe,
No.
you know, not, yeah. So it can be 9 million something, or it can be, you know, a few stars less than 9 million. So we don't know. We don't know about those last trailing zeros. Those last trailing zeros are estimates. We are not sure. So when we are not sure about a digit, it's not significant. Okay, and this is only for the trailing zeros, not for the leading zeros. The leading zeros, remember, the leading zeros give us accuracy. So remember, I gave you this example for the leading zeros. Where did that go? Yeah. You know, for leading zeros, I told you that they are not significant because if we count them, you know, if we are like, for example, we are converting from a smaller unit to a bigger unit, we will have a lot of decimal places, but that does not mean that we are increasing the accuracy. Okay, the accuracy is the same. Therefore, we don't count the leading zeros. Okay. Did you understand, Abdul Wadud, or are you still confused?
I'm still confused.
Why? What's your confusion? Tell me.
Like when we convert these 25 centimeters into kilometers, those leading zeros should also be counted as significant.
Okay, if we count them, then that means there are how many significant figures? 1, 2, 3, 4, 5. So this is really accurate. You have 5 significant figures. That means this is very accurate. But this 25 centimeters, which is your actual measurement, this you actually measured, this you got by conversion. This is your actual accuracy. Actual accuracy is only 2 significant figures. So how come you got a number which is more accurate than a less accurate number? You cannot get a more accurate number out of a less accurate number, can you?
No.
Yeah, so that's why scientists decided that we will not count these. Okay?
Okay, I now understand.
Yes, and another thing, another way of understanding it is that, you know, remember these 0.00s are also sort of estimates. Like, you know, there can be errors. Can be 0.1, you know? You understand? So, but don't
Yes.
confuse yourself too much.
Okay.
Okay. So, will you do this question with me? Or no? Or should I choose somebody else? Okay, let me. I will choose somebody who has not raised hand. Atika. Atika beta. I'm trying to unmute you. Atika. I'm trying to unmute you.
Yes,
Okay.
ma'am.
Yes. Can you do this question with me? So round this final answer to the appropriate number of significant figures. Can you do this?
Now I cannot hear you clear. Your voice is cutting.
Sorry?
Your voice is cutting. I can't hear you clear.
Oh, you can't hear me clearly? Okay. Alam 35. Yes. Alam? Okay, Saadullah. Yes,
Ma'am, the answer will be 50100.
yeah, also explain me. Don't just give me final
Ma'am,
answer.
because it is 5621 multiplied by 893,
So
and
how many
893 has the
significant?
lower. The first one has 4, the second one has 3. So we will choose the smaller one, and
Yes.
then we will round to that number of significant digits. So
Right. So
50103. Then we will check if one is smaller than 5 or not, and then we will
no. So we want
5010.
yeah, so we want till 1, right? And so 9 is greater than
Yes.
5. 9 is greater than
Alright.
5, right? So this will move up by 1. So this would be 502.
So 502. Yes.
502, and the rest will turn into zeros.
Okay.
0, 0, 0. Okay, so I'm out of time. Okay, I will finish here. And then in the next physics class, we will continue with this, but we are almost done with the significant figures, but this is very important. Okay, okay. Assalamu alaikum wa rahmatullahi wa barakatuh.